Hey, welcome. So now we're looking at task 9.3, looking at some more probability statements based on our two-way table. Taking a look at this, the first question was, let's say you just had this data. It looks like chocolate's more preferred, but maybe that wasn't the case. Why might it be less valid? Well, this is less data, right? If you don't have enough data, you don't have enough confidence in the results that you came up with. So here's another scenario that they have. Two choices, fish or chicken, grilled versus fried. All right, so here it is. Chicken or fish, grilled or fried. Now, they give you percentages, so you're not going to actually know the numbers unless you were able to get like the total number of fried and the total number of fish or something like that, but you need numbers from each of those factors. This Venn diagram, the probability statements that you know from this circle is fried, and this circle is fish, right? And the intersection is both, right? So one of the things you can do is, what's the probability of fish and fried? That would be the 15% right here. You can also write that P of fish intersect, this is the intersect symbol, which is the same as and, fish intersect fried. All right, some other ones, this is, you could get the probability of fish and grilled because it's not part of the fried circle that's here. Okay, so this is P of fish and grilled, and again there's that intersection symbol. That means and then the same thing here, P of chicken and fried. So this piece right here is not part of fish, so it must be part of chicken, but it's still within the fried circle, so you say fish and fried, and then C for intersect with fried. Now these other ones are pretty good. I'm going to focus mostly on the shading on these. Let's do this. So the first model is the probability of fish. Well, that's everything in the circle out of the total. Fried fish, well, that would be the intersection. Fish and grilled, so they want the fish but not fried, so fish and grilled is going to be something like that. This is the tricky one. It's this or clause. So it's the first time that they've introduced the or clause. Notice it's the same as the union symbol. So this or and this union symbol, they mean the same thing. So what we can do to figure this out is the probability of fried, which is here, plus the probability of fish, which is here, but notice that intersecting area I counted twice. So I have to subtract out the intersection once, and that would be, let's use a different, so we would have to subtract out this centerpiece because we've counted it once in the circle for fried and once in the circle for fish, but we only want to count it once. We can also get the actual numbers by using this equation, P of fried. So if we look at P of fried, 20 plus 15 is 35. P of fish, so 30 plus 15, which is 45, minus P of fried and fish, which we've now counted twice, which is 15%. And so now you can see 35 plus 45 is 80, minus 15 is 65%. That is the hardest one on here, I think, for folks to understand. And then the last one is not fish, not fried. Well, it has to be outside the circle. And so it would be everything here.